All right. So, what we learned in our last lesson is we got an inscribed angle here. Here's an inscribed angle right here. Okay? And so let's say angle ABD is like 70 degrees. Okay? So what would that make this arc right here? 140. And let's say this angle right here is like 40 degrees. Okay? What would make this arc up here, BC? Okay? That would make this 80 degrees. Now, what's 70 and 40 add up to? 110. So what's left for this angle right here? 70. So what is angle 1? Angle 1, so it makes a straight line, so there's 180 degrees. So if 70 is over here, angle 1 would be 110. Now, what's 80 plus 140? 220. And what's half of 220? 110. Notice the relationship between 110 and 110 here. Now, if I would change a couple numbers here, if I would make this 60 and this 50, that would make this 100, and this in 120, and this 110 here. Okay? What's 120 plus 100? 220, which would make this 110. So, we have a little theorem that goes like this. Whatever this angle is, okay, it equals 1/2 of this arc plus this arc. Okay? This angle right here equals this arc and this arc. So angle 2 over here would equal, let's call this M and this N. Angle 2 would equal 1/2 of M plus N. Okay? Because they're all in a line here. Okay? These are in a line right here. Okay? So the arc that gets cut off by this angle is this arc and this arc. So what you do is you take 1/2 of these two arcs, add them together, and you get this angle. Okay? Now, that is displayed right up here in this drawing. So this angle number 1 equals this arc, not the top arc or the bottom arc, because 1 cuts off this angle and its opposite angle. Okay, so you take these two angles, you add them up, and take 1/2 of that, and you get this angle. Okay? Now, the other ones that we have with secants is this angle right out here. If the angle's on the outside, we take 1/2 of the big arc minus the little arc. Okay? 1/2 of the big arc minus the little arc. And that we get this angle. That angle out there equals 1/2 the big arc minus the little arc. If you have a secant and a tangent, here's a secant, here's a tangent. Okay? This angle out here equals 1/2 of the big arc that cuts it off minus the little arc. Okay? Not this arc out here. Okay, that doesn't matter. This one out here doesn't matter. It's the arc that the angle cuts off, the big arc minus the little arc. Take 1/2 the big minus the little, you get that angle. If you have two tangents that cut it off, okay, the angle equals 1/2 of the big arc that gets cut off minus the little arc that gets cut off. Okay? So 1/2 of big minus little. So if the angle's on the inside, we add up the two arcs that gets cut off. The angles on the outside, we subtract the two angles that gets cut off. All right. So let's figure out angles here. Let's figure out this angle right out here, angle 1. Angle 1 equals 1/2 of the big arc, AD, minus the little arc, AC. What's the problem with that? What's the problem with what I just wrote down here? We don't know the little arc. But can we figure it out? Yeah. There's 360 degrees in a circle. 151 and 139 add up to like 290. What's 360 minus 290? 70. So this arc is 70. So angle 1 equals 1/2 of 151 minus 70. Angle 1 equals 1/2 of 81. Angle 1 equals 40.5. The angle equals 1/2 of the big arc minus the little arc. The angle J in this case, equals 1/2 of the big arc, LM, minus the little arc, KN. So, what's angle J? 34 equals 1/2 of the big arc, 6x plus 6, minus the little arc, 3x minus 5. Now, this one's a little harder because it has variables in it. So 34 equals 1/2 of, what's 6x minus 3x? 3x. What's 6 minus a negative 5? Plus 11. Minus a negative is plus a positive, so it's 6 plus 5, which is 11. Got to be careful there. Now, do you like working with fractions? No. People don't like working with fractions. So if we would distribute this fraction through, we'd have all kinds of fractions. We don't like that. There's an easier way to work with this problem. If you multiply both sides by 2, we get rid of that fraction. Gone. 68 equals 3x minus plus 11. Okay? See how that works? Just got rid of that fraction by multiplying by 2. Now no more fractions. Subtract 11. So 57 equals 3x. Divide by 3. X equals 19. Easy peasy lemon squeezy. All right. They want to know what this angle or this arc out here is, WX. Well, the angle on the inside equals 1/2 of one arc, ZY, plus the other arc, WX. So angle 1 is what? 107 equals 1/2 of 74 plus X. So now we got to solve this. Again, we don't like fractions, right? So to get rid of the fraction of 1/2, we do what? Multiply by 2 on each side. So 214 equals 74 plus X. Then what do we do to each side? Subtract 74. We get 180. X equals 180 degrees. Okay? The angle out here equals 1/2 of the big arc minus the little arc. Now, if this is 152 and 126, what's left for the little arc? Well, 126 and 152 is 178. So this must be 278. So then that just leaves us 82, right? Am I right? Okay. So angle 1 equals 1/2 of the big arc, 152, minus the little arc, 82. Make sure you use these two arcs and you don't use this one because that's outside the angle. Okay? So angle 1 equals 1/2 of the big arc minus the little arc, 1/2 of 70. Angle 1 is 35. If JK is 69, KL is 44, LM is 163, what's angle Z? Well, to figure that out, we need to know what JM is, right? Okay. Well, 69 and 44 make 113. Hi, Anna. And then we have 163. We add those up, well, it's 276. So if we take 360 minus 276, what do we get? 84. So angle 1 equals 1/2 of the big arc. What's the big arc here? 84 minus the little arc of 44. Okay, we don't use this and we don't use this because we use the arcs that are inside the angle. So it's 1/2 of 40, which is 20. Okay, next concept. Now we're dealing with lengths of chords. So if you have two chords across inside the circle, this side of this chord times this side of this chord is going to equal this side of this chord times this side of this chord. This times this equals this times this. Okay? And again, on this chart, it's right over here. AX times CX equals BX times DX. This times this equals this times this. Then, when you get a situation like this with two sequence, the outside times the whole thing equals the outside times the whole thing. The outside n times the whole thing, m plus n, equals the outside q times the whole thing, p plus q. Okay? When you have a tangent and a secant, it works the same way. The outside times the whole thing, x times x is x squared, equals the outside z times the whole thing, z plus y. So solve this one. When it's on the inside, we just take the parts times each other. So, Charisma, what are the two parts? Why don't you wake up, get your head up off the table. Let's go. Okay. You take this part of this chord times this part of this chord. 4 times x equals this part of this chord times this part of this chord. 5 times 6. So 4x equals 30. If we divide by 4, x equals 7.5. That's how long this line is. Okay? Easy peasy lemon squeezy. So how do we figure out y? How do we figure out y? What times what equals what times what, Max? Exactly. Okay, so 10y equals 105 divided by 10. Y equals 10.5. Okay. Okay, archaeologists found part of a wall that surrounded an ancient city. Now this distance from here to here was 272. This distance out here was 310, and inside the wall was 805. So they replicated these distances. What they want to know is, how big is this diameter of the wall around the city? How large was the wall around the city? Well, what we don't know is this here. So you take the outside 310 times the whole thing here, 310 plus 805. Okay, outside times the whole thing should equal the outside 272 plus the whole, or times the whole thing, 272 plus x. So the outside times the whole thing equals the outside times the whole thing. Okay, I'll need help with calculators here. 310 plus 805, I know that is 1115. So what's 310 times 1115? Pretty big number. 300 and some odd thousand. Okay, what's 272 times 272? $984 plus 272x if we do the distributive property. So 73,984 plus 272x equals 345,650. So if we subtract 73,984 from each side, that should equal 272x, whatever that is. So it should be 27,000 something. $271,666. Then divide that by 272. Hello. Mm-hmm. Yeah. Um. That's a good question. I'll think about that. I'll maybe ask Casper quick. All right. All right. Sounds good. Yep. Bye. Okay. 271,666. So this would be like 99 point something, right? 98 point something, 99 point something. What is it? 998.8. Basically, that city was 1,000 meters wide. 998 meters, 998.8. Basically, that city was 1,000 meters wide. Okay? We're just about done here. Okay? To figure out A here. Ooh, that one's a little harder. I don't think we have one of those on the homework. I'm not going to mess with that one. Okay. To figure out this one, the outside times the whole thing, 87 times 87 plus x equals the outside 80 times the whole thing, 80 plus 210. So 80 times 290 over here, and 87 times 87. What's 87 times 87? 1569, 7569 plus 87x equals 80 times 290, which is 0, 0, 2, 23, 7569 plus 87x. So if we subtract 7569, 87x would equal 15,631. Divide by 87, and you get about 180. Okay? So here are the formulas that you use today. I'm going to leave those on the board for you. Okay? So I'm going to have you get started. If you get stuck, ask questions. I had somebody sit for 45 minutes, didn't know how to do problem number 1, so they just sat there and looked at it yesterday for 45 minutes. And then I walked over and it's like, oh, I didn't know how to do number 1. Well, ask a question if you don't know how to do it. I'm not that mean. I might yell sometimes, but I'm not that mean. Okay? Ask a question if you don't know.